Hi friends, welcome to our YouTube channel Knowledge Academy. The main aim of this lecture is to discuss about the UPSC main solutions of the signal and systems of previous year questions in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. When we upload a new video, the direct notifications comes in mobile. If any improvements needed in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. So why to waste more time? So let's get started. So now we are going to solve the first question. See the question here. Use the properties of the unit impulse function delta of t to evaluate the following integrals. So integral t is equal to minus into plus into t square plus cos pi t into delta of t minus phi dt, and the second one is integration minus into plus into e to the power of minus pi t plus sine of 10 pi t into delta of 2t plus 1 dt. These are the two integrals we need to figure out. So this question is given in the IAS 2002 for 20 marks. So let's solve this numerical. So now we are going to solve this numerical. See the question here. This is the two integrals we need to figure out its value. So therefore here the basic principle of the shifting property of the impulse signal is very thing, which is integration minus into plus into f of t delta of t minus t naught is nothing but f of t naught. Means this is going to have only at t is equal to t naught only this function is going to have value, because the impulse signal is going to have a unit area only at t naught, and remaining all of the time it is going to have zero value. So that is the reason this integration is going to converge to only one value, which is f of t naught. So therefore here f of t is equal to this one. So therefore t naught is equal to 5. So therefore this function is only going to exist at the t naught value. So therefore at t naught is nothing but 5. So therefore y of phi is equal to, this is the f of t. So therefore in place of f of t you need to substitute t naught. T naught is nothing but 5. So therefore here in the place of t you need to substitute 5. So therefore phi square plus cos of phi into pi. So therefore this is nothing but cos 5 pi. Basically cos n pi is equal to minus 1 over to the power of n. So when n is equal to odd number means 5, so therefore minus 1 over to the power of 5 is nothing but again minus 1. So therefore cos of 5 pi is nothing but minus 5. 5 square is 25. 25 minus 1 is nothing but 24. So therefore this integral is going to have only at one value, which is at only at one instant t is equal to 5, it is going to have a non-zero value. So therefore the y of t is equal to, this is the integral y of t is equal to, it is going to have value of 24 for only t is equal to 5, and remaining all other instance this value is going to have 0. So this is for the first one, and the second part is, this is the second integration we need to do. So basically the basic formula of the impulse is delta of at is equal to 1 by mod a into delta of t. So therefore now if you are going to elongate or whether you are going to compress in the time domain, and this is the way you are going to get 1 by mod a delta of t. So therefore if you elongate or if you compress the impulse signal, this is the function you are going to get 1 by mod a of delta of t. So therefore now here delta of 2t plus 1, I can write it as 2 I am going to take as a common. So therefore delta of 2 into t plus 1 by 2. So delta of at is nothing but 1 by mod a into delta of t. I am assuming all this as a t. So therefore 1 by mod 2 is nothing but again 2. So 1 by 2 delta of t plus 2. So now I am going to write here, in place of here I am going to write here, see y of t is equal to, so in place of delta of 2t plus 1 I am going to write 1 by 2 delta of t plus half. So therefore this is the thing I am going to get. So if you see carefully, this is also in the same fraction, which is integration minus into plus into f of t delta of t minus t naught is nothing but f of t naught, because this function is going to have, this impulse function is going to have only unit area at only t is equal to t naught, and remaining all other instance its value is 0. So therefore that is the reason, and this is the now f of t. So in place of f of t I need to substitute here, because here f of t minus t naught is nothing but, we can write here minus of. So therefore t naught is nothing but here now minus of. So therefore in place of t you need to substitute minus of. So therefore here this is a function f of t, right? So in this you have to substitute t is equal to minus of. So therefore now e to the power of minus 5 into, in place of t minus of, sine 10 pi into minus of. So therefore now if you substitute here, so minus into minus is nothing but plus. So e to the power of pi by 2, and this is nothing but here minus, and 5 pi is nothing but there is a minus, so minus is going to come outside. So minus sine phi, because sine of minus theta is nothing but minus sine theta. So therefore now sine n pi is always equal to 0, no matter whether it's n is even number or it is odd number, always sine n pi is equal to 0. So therefore sine n pi is nothing but 0 now. So therefore only non-zero values e to the power of pi by 2. So therefore at t is equal to minus half, we are going to get e to the power of pi by 2, and remaining all other instance its value is 0, and that is what I have written here. So y of t is equal to half into e to the power of pi by 2 at only t is equal to minus half, and is equal to 0 for all other instance. So these are the two integrals we have did here. So now we are going to solve the second question. See the question here. So develop the relation between the unit step sequence and the unit sample sequence. So we need to find what is the relation between the unit step sequence and the unit sample sequence. The unit step sequence is nothing but unit step signal, and the unit sample signal is nothing but impulse signal. So therefore here this question is given in the IAS 2004 for 4 marks. So let's solve this numerical. So in this question, the agenda is we need to find what is the relation between the unit step sequence and the unit sample sequence. The unit step sequence is nothing but u of n. So it is going to have a value 0 for n less than 0, and it is going to have a unit value for n greater than or equal to 0. And this is the graph. So therefore we are going to take a discrete time system. So therefore now n is going to take only the integer values. So at n less than 0, its value is 0, and for n greater than or equal to 0, we are going to get a value 1. And similarly for the unit sample sequence, the unit sample sequence is nothing but impulse signal. So delta of n is equal to, it is going to have a value of 1 for n is equal to 0, and it is going to have a value of 0 for n not equal to 0. Means except 0, all other values it is going to have value 0, and this is the graph of the delta of n. So therefore at n is equal to 0, we are going to get the value 1, and remaining all other instance its value is 0. So now we are going to find the relation between these two signals, which are the unit step sequence and the unit sample sequence. So now I am going to write here in what is the term of the expression of the delta n in terms of the u of n. So delta of n is nothing but u of n minus u of n minus 1. It simply is nothing but here, if you come here, up to here there is 0. So therefore now you have to rise by 1. So therefore plus u of n, and then after coming here you have to decrease by 1. So therefore minus of u of n minus 1. So therefore this is also an easy way. So therefore you are going to get delta of n is equal to u of n minus u of n minus 1. So therefore this is the expression of the unit sample sequence in terms of the unit step sequence. So simply we can write it as it is the first difference of the unit step sequence. So therefore the unit sample sequence is nothing but it is the first difference of the unit step sequence. And similarly now I am going to write what is the expression of the u of n in terms of the delta of n. So there are two expressions for this one. See, u of n is equal to sigma k is equal to minus infinity to n delta of k, or sigma k is equal to 0 to infinity delta of n minus k. These are the two terms which are valid for the expression of the u of n in terms of the impulse sample signals. So unit sample sequence or impulse signal, you can tell any of the term. So therefore now this is nothing but this unit step sequence is nothing but it is a running sum of the unit sample sequence. Yes, this is a sigma is nothing but summation. So therefore unit step sequence is nothing but it is a running sum of the unit sample sequence. So therefore now this is the relation between the delta of n in terms of u of n and the u of n in terms of the delta of n. These are the two valid expressions, and if you write in this manner you are going to get definitely 4 marks in the IAS examination. So now we are going to solve the third question. See the question here. How can you express a discrete signal as a sequence of a sum of scale delayed unit sample sequence? This question is given in the IAS 2004 for 4 marks. So in this question they are asking that how you can express any discrete signal in terms of the unit sample sequence or unit impulse sequence, we need to figure out. So here this question is given in the IAS 2004 for the 4 marks. So let's solve this numerical. So in this question we need to write any discrete signal in terms of the unit sample signals, we need to write here. So let me assume the discrete signal being, so this is the discrete signal I am going to assume, because here n is going to take only the integer value. So therefore 0, 1, 2, 3 and it goes on. So at each and every time instant I am going to take its amplitude values x of 0, x of 1, x of 2, x of 3, x of 4. So for all time this is the amplitudes. So at each and every instant of time the amplitude is, so suppose at t is equal to 2 means the amplitude value is x of 2, and similarly for each and everything. So let me assume this is the discrete time signal. So now this discrete time signal I need to express in terms of the unit sample signals or the delayed version of the unit sample signals, we need to figure out. So therefore now, and the unit sample sequence B, this is the unit sample sequence, at n is equal to 0 value it is going to have value 1, and remaining all other instants its value is 0. And similarly the delayed version of the unit sample sequence is, so therefore now delta of n minus k. So at n is equal to k only, at n is equal to k it is going to have value 1, and remaining all other instant its value is 0. So therefore now with the help of this I am going to write this expression. So therefore x of n is equal to, so x of minus 4 into delta of n minus of minus 4, and similarly x of minus 3 into delta of n minus of minus 3, and similarly x of minus 2 into delta of n minus of minus 2, and similarly x of minus 1 into delta of n minus of minus 1, and similarly x of 0 into delta of n minus 0. So therefore x of 1 into delta of n minus 1, and similarly x of 2 into delta of n minus 2, and similarly x of 3 into delta of n minus 3, and similarly x of 4 into delta of n minus 4, and this goes on for each and every time instant. So therefore we have to write this one from minus infinity to plus infinity. So therefore this is what I have written here, from minus infinity to plus infinity. So simply all these things we can simply write it as x of n is equal to sigma k is equal to minus infinity plus infinity x of k in delta of n minus k. So let me take here when n is equal to plus 2, so means x of 2 into delta of n minus 2. Yes, it is there. So x of plus 2 in delta of n minus 2. So therefore if you take n is equal to minus 1, so therefore x of minus 1 into delta of n minus of minus 1. Yes, it is also there. So therefore we can conclude that this impulse signal, this discrete impulse signal we can, so therefore any discrete signal we can write it as a summation of the scaled version of the delayed sample sequence. So I am repeating it again. So therefore you can write any discrete signal as a summation of the scaled version of the any delayed unit sample sequence. So therefore this is the way. So finally we have expressed any discrete signal in terms of the delayed version of the unit sample sequence we have represented in this manner. So therefore if you write in this manner, you are definitely we will get 4 marks. Now we are going to solve the fourth question. See the question here. A continuous time LTI system is described by the equation y of t is equal to 1 by t integration t minus of minus t by 2 t plus t by 2 x of tau d tau. Find the impulse response of the system and is the system causal. So now in this question they have given a input and output relation of some system of LTI system, and we need to find what is the impulse response of the system, and then we need to figure out whether this system is a causal system or non-causal system. We also need to comment, and this question is given in the IS 2005 for the 5 marks. So let's solve this numerical. So this is a LTI system. The input is x of t and the output is y of t. So therefore for this LTI system they are given that the relation between the input and output of the LTI system is y of t is equal to 1 by t integration t minus t by 2 t plus t by 2 x of tau delta of tau. So now we need to find what is the impulse response, and then we need to comment on the causality. So therefore if the input is delta of t, means if the input is impulse signal, then the output we are going to get is as a impulse response. So therefore here if the input is x of t is equal to delta of t impulse signal, the output y of t will be impulse response. So therefore in place of x of tau I need to substitute here delta of tau, and similarly in place of y of t I need to substitute here h of t. So therefore y of t means h of t and x of tau means nothing but just replace t by tau. So therefore delta of tau. So this is the relation of the input and output. So therefore now see integration of any unit impulse signal is nothing but here unit step sequence. So therefore integration of the unit sample sequence or the unit sample sequence is nothing but the unit step sequence. So unit step signal. So 1 by t this is u of tau, and the brackets is so d plus t by 2 t minus t by 2 integration limits. So upper minus lower, so therefore upper limit minus lower limit. So this is the value. So therefore this is the h of t 1 by t u of t plus t by 2 minus of u of t minus t by 2. So here the value is t by 2 and here minus t by 2. So here positive, so therefore plus t by 2, and at t is equal to t by 2 there is a minus, means we have to go down. So finally this is the figure. Finally this is the diagram of the h of t. So this is the impulse signal, this is the impulse response signal diagram. So therefore now we need to comment on the causality. See here this is the expression, right? So let me assume at t is equal to 0. So what is the expression at t is equal to 0? See y of 0 is equal to 1 by t. So at t is equal to 0 means minus t by 2 plus t by 2 x of tau d tau. So this is the expression I am going to get. See when the time is equal to 0, this input is going to depend upon t by 2, means greater than 0. So therefore here the output is going to depend upon also the future values of the input. So therefore we can conclude that this system is said to be a non-causal system. In another fashion also, by just seeing the impulse signal response, impulse sequence response or impulse signal response, we can tell that one. See here h of t is going to have a non-zero value at t less than 0. So therefore we can conclude that this system is said to be a non-causal system. If the impulse signal has zero value, it has zero value for t less than 0, then we say that system is said to be causal, but here it is not equal to 0. At t less than 0, it has a non-zero value, then we can comment that this system is said to be a non-causal system. So either by the two methods we can tell the system is said to be a non-causal, because here the output is going to depend upon the future values. At t is equal to 0, it is going to depend upon t by 2. T by 2 is nothing but greater than 0. So therefore we can conclude that this system is a non-causal system, and this is the diagram of the impulse response. So now we are going to solve the last question of this lecture. See the question here. The discrete time system is described by y of n is equal to x of n plus n into x of n minus 1. Check whether this system is a causal time variant. So this is the input output relation of a system also they have given. So now we need to comment on the two properties, which are the causal property and the time variant property. So whether this system is a causal system or the time variant system, we need to comment. And this question is given in the IAS 2010 for the 5 marks. So let's solve this numerical. So this is the equation that is given in the question. So we need to comment on the causality and the time invariant properties of this system. We need to comment. So here let me assume at n is equal to 1, means at instant n is equal to 1, here x of 1 and here 1 into 1 minus 1 is nothing but 0. So this is the equation we are going to get. So here that present output is going to depend upon the present input and the past input. And similarly for n is equal to 2, at instant 2 we are going to see here x of 2 plus 2 into x of 2 minus 1 nothing but 1. So here also at the present instant of the output is going to depend upon the present value of the input and also the past value of the input. So therefore again suppose let me take here finally at n is equal to minus 1. So therefore here x of minus 1 into x of minus 2. So therefore now here the present value of the output is going to depend upon the present value of the input and the past value of the input. So we can conclude that here the output is not going to depend upon the future values of the input. See, if the output is dependent of the future values of the input, so it is not going to depend upon the future values of the input, then we can say this system is said to be a causal system. So therefore here the output is going to depend upon only on the present values of the input and also the past values of the input, and it is independent of the future values of the input. So therefore we can say this system is said to be a causal system. And similarly here for the same system, see if input is x of n means this is the output they have given. So now we need to check the time variant, or that this system is a time invariant or time variant we need to figure out. Similarly for the same system, suppose if the input is x of n means the output is y of n, and if the input is x1 of n means the output will be y1 of n. So input is nothing but here x1 of n plus n into x1 of n minus 1. Suppose if the input is a delayed version of the previous input, so therefore here if x1 of n, so therefore x1 of n means nothing but here x1 of n is nothing but x of n minus n not. So substitute here, and similarly n into x1 of n minus 1 means in place of n substitute n minus 1. So x of n minus 1 minus n naught. So this is the thing we are going to get. So this is the actual output we have got from this system. So if you are going to give some amount of delay in the input, this is the actual output we are going to get. So now see what happens for the time invariant system. So for time invariant system, if the input is x of n and the output is y of n, if the input is a delayed version of the previous input, the output must be a delayed version of the previous output. Then only we say that system is said to be a time invariant system. So now let us check what is the value of y of n minus n naught. We know the value of y of n, which is x of n plus n into x of n minus 1. So in place of n substitute n minus n naught. So wherever n you will see substitute there n minus n naught. So therefore here x of n minus n naught plus n minus n naught into x of n minus n naught minus 1. So this is the expression we are going to get. And if you see carefully, these both are not equal because here n is there and here n minus n naught. So we can conclude that these two are not equal. So therefore we can conclude that this system is said to be a time variant system. See, for time invariant system, this is the output we need to get, but the output which we got is not going to has the same value of this one. So therefore we can conclude that this system is said to be a time variant system. Means the output, if the input is a delayed input, the output is not the delayed version of the output. So therefore we can say this system is said to be a time variant system. So finally from this system, the input output equation, we can conclude that this system is a causal system and it is also time variant system. So by this lecture we have successfully completed the 5 questions which are the previous year UPSC main solutions of the signal systems in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button so whenever we upload a new video the direct notifications comes to your mobile. If any improvements in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. Thank you so much for watching this lecture. Keep smiling, take care and bye bye.